Yes, and thank you so much. And good afternoon, good evening, everyone. And it's a pleasure to be here. I really want to thank John and Binay and Beyond Binay for giving me this opportunity to share my thoughts. Actually, I became a member of the community about 2 years ago. I was invited to join by Samson, who works a lot with Natasha. And since then, I have been participating in the programs. And from there, I just developed an interest to try and see how I can also, at my own local institution, how I can also create start engaging and starting the conversation around green chemistry. So I'll just share my thoughts on what we are doing, because we are still very early on how we are beginning to think about integrating green chemistry into education curriculum in Nigeria. And I just like to start by introducing Nigeria in case some of us may not know much about Nigeria. So these are just the sights and sound from Nigeria, in terms of the capital city being Abuja and some of our delicacies. So I'll come back to this plantain, roasted plantain, because this is a delicacy in where I'm located, and I'll say a little bit more later. So Nigeria, you know, sometimes people think about Africa as being one country, but actually Nigeria is in a continent of Africa with several countries there, and is in the western part of Africa. And those are some of the basic facts. So then comes to Nigeria. So where I'm actually located, I'm located in the southern part of Nigeria. So Nigeria is a country with 36 states, and is the most populous African nation. It's multilingual, and is one you have when you hear about Nollywood, and soccer is one of the popular sports in Nigeria. But in terms of resources, we are the 10th in terms of all reserves in the world. And then I also like to just introduce my university briefly. So some of the basic facts. So my university is pretty much new. It was founded, established in 1991. We currently have a student population of over 26,000. We operate 4 campuses, and then we have 18 faculties. We are a public university, and we are being funded by the federal government of Nigeria. So this now leads me to my talk about education system and how we plan to integrate it in Nigeria. So Nigeria's education system since 1973 operates a 6334 system. So you have the 6 years of elementary or primary education, and then the 3 year of junior secondary, and then 3 years of senior secondary. And then for the chemistry program it's a 4-year program. So at the elementary level, at the primary level, the students, depending on where you're located or whether you are in the public or private stream, but definitely mainly you have a maximum subject of 16 and a minimum of 15. And in those subjects, you have where green chemistry can be located is where you have the basic science or the basic technology. So within the basic science curriculum, you have contents that includes like exploring our environment, non-living thing. And then under the basic technology, where the students are taught about the energy and understanding basic technology. And then as they move on from that there to the junior secondary, those topics kind of repeat themselves, but in a more detailed and more specific way. So in the junior secondary, like you have topics when you're talking about environment, there are topics like includes environmental pollution, climate change. The students begin to be introduced into those topics. And then still under the basic technology component, is where the students are actually taught materials and processing, and then they're taught about safety and then understanding basic technology. So as they move from primary, so they begin, so the curriculum does not really focus entirely on the green chemistry, but you do have elements of green chemistry as topics in there. And then they go into the secondary education. At the secondary education, they are also expected to take a maximum of 12 subjects and then a minimum of 8. But at that level now, they get into taking chemistry. And the chemistry curriculum at that level includes the traditional chemistry, where you're talking about inorganic, organic, analytical, polymer, industrial chemistry at that level. Those are basic. And we do not really have a program where we are really a content where it's more really green chemistry, but you have components of green chemistry in all of this. And then they come to the university. At the university again, traditional, because from the secondary school, they come to the university. And the university, I'm talking about the undergraduate chemistry program, because at the university level, you have various chemistry programs. You can have medicinal chemistry, you can have industrial chemistry, you can have petroleum chemistry, and all of those programs have different content. But for the basic chemistry program, you also have the traditional inorganic, organic, physical, analytical, polymer, industrial, computational. At the environmental chemistry level, you just have introduction where you are talking more about the about the natural resources, the water, the cycles in nature, the hydrogeological cycles, and then they begin to be introduced into waste management, water resources and management and all of that. And then they also, there's a content on nuclear and radiochemistry. So now within this context, now we have had this context since 1973, even though through at some point there's been updating of the content, there've been reviews of the content. But if we look at it from then to now, how much have we achieved in terms of matching that with sustainable development goals? So I got this slide from Samson that spoke in February. So how has our curriculum helped us in achieving sustainable development goals? And well, we may say not so much, because in most of the targets of the Millennium Development Goals, my country, for instance, did not meet most of those targets. So which means that we need to still do a lot, or we need to inject more of green chemistry into our education curriculum. And how do we get about that? So recently, we were fortunate to have a funding from the American Chemical Society. And through this funding, we had a program where we brought the stakeholders in the education sector into to an engagement forum. That engagement forum, we called it Academia, Industry, and Government Engagement Forum. We're just trying to have the conversation around green chemistry, introducing green chemistry into education curriculum started. So the first day was dedicated for the education, where we had the teachers and the government and the regulators, the principals, and then we introduced them to green chemistry and the need for us to begin to think about including it into our curriculum. And then the second day, we had the business people, the industry executives, again, also talking green chemistry and the need that we need to transit from the current practices to a more sustainable practice. And then showcasing the important role of green chemistry in this transition. We're fortunate, we had a lot of organizations. We had UNEP, representative from UNEP, and all of these organizations were part of that event. So we are really thankful to ACS for helping us to start this conversation. So at the end of the first day, what are some of the key things that came out of that engagement forum, particularly on the aspects of introducing green chemistry into our education curriculum? So one of the things there that was highlighted as an issue and a challenge is that we have to look at the methods and the pedagogies. How do we make it interesting so that the students, even from the primary level to the secondary level, will become interested? And then there was this other issue about teacher education, that maybe we really have to start introducing it into our teacher education curriculum. And then what about the scope? Because I mean, like what the teachers said and what the stakeholders said was that there are components of green chemistry, like I presented earlier, in some of the topics, like in the basic science, in the basic technology. But then if you match that with the United Nations and UNEP Education and Green and Sustainable Chemistry Manual, there are some gaps. So the question about scope, about teacher curriculum, and about the methods came on. So what the take from that is that, I mean, it's a process. I like what John said, that the system thing. So it's a process. It's not going to be an overnight thing, but at least we have started the conversation. So it's just for us to keep on the conversation and then take one at a time. And I really want to appreciate all the resources that have been exposed to here, because that will really help us make things easier for us. So that is at the primary and secondary level, that's primary and high school level. And then coming to the tertiary institution level, we had a unique opportunity, because currently the regulating body, the National University Commission, has been working on these documents to try to harmonize the curriculum across Nigerian universities. And it's called the Core Curriculum Minimum Academic Standards for the Nigerian university system. And it has 10 of this unique feature. But the important thing there is that it's tailored towards deploying science and technology in addressing societal problems. And societal problems, sustainable development comes into here. So this offers us in the university a unique opportunity for us to propose to include green chemistry in our curriculum. So what this document does is that there's a 70% that is going to be uniform across all the universities in Nigeria, whether you're looking at chemistry program. And so for us in the University of Uyo, as part of our own 30% inclusion, so we have introduced this green chemistry and toxicology program, and then we have also introduced a green production. So the idea is that when the students come in at the undergraduate, we'll expose them, they'll take a course in green chemistry and toxicology. And then as they are graduating, they should be able to use that knowledge to come up with some innovation, some innovative products and services based on the principle of green chemistry. So I want to acknowledge, and we are grateful to Benign for all these resources and UNEP, because these are all the resources. They have done the hard work for us. So we are just using these resources to develop our content. So currently where this is that currently this has been submitted. We have submitted this as a department to the National University Commission. So we are expecting approval, waiting on approval for that. And then from there, maybe, hopefully, we will start the implementation. So with this now, we will be able to actually integrate green chemistry into our undergraduate chemistry program at the University of Uyo. So I just want to briefly share and talk about my research a little bit. So I'm from the Niger Delta region of Nigeria, and one of our key challenges is that we are the home base for oil and gas in Nigeria, and as a result of that, we have a lot of spills and these spills kind of affect our water resources. So the spills and even the geology, the geology from this area as well, so that even if you just dig maybe 10 to 15 meters, you see hydrocarbon floating in water, in your groundwater. So this is one of our major challenges. And so I decided to focus my research into water chemistry and coming up with solutions to address these challenges. So where does so for us, green chemistry plays a role because we just want to move from monitoring into remediations and links. So we want to change our brown fields into green fields. And we know that green chemistry plays a role in here. So that's where our focus of research is. So in terms of monitoring, we monitor various parameters from metals to emerging contaminants to radionuclides, and recently we introduced microplastics as well across our local region. And if they are interested, if anyone is interested there, we have all the publications there in my pages there. And then we also look at, so where again green chemistry comes in, we also look at treatments. So we are looking at some of the biomaterials now to replace some of the materials, the hazardous materials. So when again I mentioned about plantain, so we do consume a lot of these. So we are looking at how we can use the waste. We have this brackish water that has a lot of humic acid. So I mean humus and humic acid, how do we extract that? And then so some of the waste. So how do we use biomaterials to come up with absorbents that can be used for water treatment? So that's one of our research area. And then we're also looking at biomaterials for nano biomaterials. So recently we've done a lot of review when we are trying to look at suitable biomaterials that we can also use for remediation of organic pollutants. So these are some of our reviews, and then we are also thinking about surfactants. Surfactants, where we are looking at again plant-derived surfactants. We are also looking at biosurfactants, to see how that can replace synthetic chemicals. So in terms of our research efforts, these are the direction that we are heading to incorporate to green chemistry. So I'd just like to thank all our partners and thank Beyond Benign and thank UNEP and all the partners and the support. In fact, since I've been a member of this committee, I've really benefited and it has helped our work because we do not need to go back and think about developing curriculum. Like I'm very happy to be aware of what John is doing because that will help us. So we do not need to go back. So all we need is for us to look at the type of experiment, see the one that we have the resources, and then we work with that and start bringing our chemistry practicals. So thank you so much, and I'm grateful.